This question here is about projectile motion. Object A is dropped from a certain height and 5 seconds later object B is projected vertically downwards from the same height. Ignore air resistance. This first question, explain what is meant by a projectile. Now remember, a projectile is an object upon which the only force acting on it is the force of gravity. Don't mistake this with the definition for free fall. Free fall is also when the only force acting on an object is the force of gravity, but you have to start by saying when an object is in motion. Right, so that's the difference between the two. The next question here, use equations of motion to calculate the following: the time taken by object A to reach a speed of 245 meters per second. So this is going to be my final velocity. My initial velocity, if it's dropped, initial velocity is equal to 0 meters per second. So if I want to calculate time taken, they've actually given me a clue in the first question by telling me that gravity is the only force acting on it. Therefore, my acceleration will be 9.8 meters per square second. So I'm going to use this formula. There are many different ways in which you can solve this question. Vf equals Vi plus A change in time, where Vf is now 245, Vi 0, and I'm going to take downwards positive for this question, so I'm just going to make a note of that so I don't forget, plus 9.8 multiplied by the change in time. And when you calculate the change in time, this is now for object A, it's going to give you 25 seconds. Then the next question, the initial velocity of object B. So we are looking for this V initial for B. If object A has a velocity of 245 meters per second until it reaches object A. So what they are actually saying is when they reach each other, because they were thrown from the same point, the change in Y is the same. So here we have to use 3.2.1 to solve this question. Remember that if you take this formula, change in Y for object A is going to be equal to Vi multiplied by the change in time plus a half A change in time squared. And now the Vi I'm talking about here is the Vi for A, and the time is the time for A. Remember that. If I look at object B, the change in Y for object B is also going to be equal to the same formula, but now the initial velocity of object B multiplied by the change in time plus a half A change in time squared. Now this time is not the same for both, but what is the same is the fact that the change in Y for A equals the change in Y for B. Therefore I can solve these two equations simultaneously, which means that I can say the initial velocity of A multiplied by the change in time for A plus a half A change in time squared for A equals the initial velocity for B multiplied by the change in time for B plus a half A change in time for B. So what is the change in time for B? If you read the question, object B is dropped 5 seconds later. So if it takes object A 25 seconds, it must take object B 20 seconds. So initial velocity of A we know is 0. 0 times anything is 0, plus a half times 9.8 multiplied by 25 squared is going to be equal to V initial for B, which is my unknown, multiplied by 20 plus a half times 9.8 times 20 squared. And if you go and calculate this, you will find that the initial velocity for B is 55.13 meters per second downwards. There are also many different ways in which you could have solved this, but I want you to focus on this technique of when two objects meet, they actually have the same displacement, and that's the important part here. So you can actually equate two equations and solve them simultaneously. Then for the next question, sketch a velocity time graph for object B from the moment it was projected until it reaches object A. So it means that we have to use the initial velocity for B, which we've just calculated, this 55.13 meters per second downwards. Now when I go and draw my graph, you are going to have to remember the basics here. When you draw a graph, you have your y-axis, velocity, unit meters per second. and on your x-axis time in seconds. So I'm going to plot 55,13 as my initial velocity at 0 seconds, and then I'm going to make a little mark at 20 seconds because that's the total time object B takes. I haven't calculated the final velocity of object B yet. It is one of my questions. So I have initial velocity, I have the time taken, but I don't have final velocity. Many ways in which you can go and calculate this. I'm going to use Vf equals Vi plus A changing time, where Vi is equal to 55,13 plus 9,8 multiplied by 20. And if you go and calculate this, it's going to give you 251,13 meters per second downwards, which is my final velocity. On my y-axis, I go and I indicate 251.13 meters per second, and I connect the y-axis with the x-axis by making a dot, and then connecting my two dots, of course, with a ruler. And now I can get my 3 marks.